Hello, pre-calc students. This is Mr. Beck. Today we're going to be talking about the graphs of tangent and cotangent. Now, when it comes to tangent and cotangent, a lot of the graphing that we're going to do is going to be very similar to how we graph sine and cosine, which means we do need to establish what are all of the decimal values for sine and cosine. We can see those decimal values for the ratios right there. Now, the biggest difference between graphing tangent and cotangent, I'm going to say right now, is we are going to focus primarily on the period of tangent that goes from negative pi over 2 to pi over 2. So the graph of tangent from negative pi over 2 to pi over 2 gives us one complete period of tangent. I did graph from 0 to 2 pi on here. I actually graphed from negative pi over 2 to 2 pi on here. So we could see that the graph of tangent does repeat itself every pi. So big difference, the period of tangent is pi, and we are going to go from negative pi over 2 to pi over 2. And we're going to look at that interval primarily. So the way we're going to graph is going to be very similar to what we did before, or the way we graphed before. We are just going to have a different starting point and different ending point, and our period is going to be pi instead of 2 pi as we do all of our analysis. So without further ado, one of the things I do want to point out is, once again, domain. In this case, x is not allowed to equal pi over 2n. Now, if you remember how I showed you that before, we could say x does not equal one of these asymptotes is negative pi over 2 plus pi n, because the distance between those is pi. And I honestly kind of prefer that, so I'm going to go ahead and scratch that out. So that's not a bad train of thought, but I just want to be consistent with what I did last time, which actually you can see that I did right here. So let me go ahead and undo that because it's valid, but anyway. So once again, there is no amplitude for tangent. There is no amplitude for tangent because the average of infinity and negative infinity is not necessarily 0, believe it or not. So we can't really average those two. So there's no amplitude. Amplitude only exists for sine or cosine. The range is from negative infinity to infinity on all of those. So the range is going to be very nice for us to be able to list because it's always negative infinity to infinity. And as I mentioned before, the period is going to be pi instead of 2 pi. Tangent is an odd function. We can see that symmetry over the origin. So tangent is an odd function. Here's going to be sort of the generic graphs of all of them. As I mentioned, tangent, we go from negative pi over 2 to pi over 2 as we graph our tangent, and you'll see us do that, or see me do that. Cotangent is going to go from 0 to pi, because if you remember, the cotangent of 0 is undefined and the cotangent of pi is undefined. So this will allow us to look at one full period of cotangent going from 0 to pi. So tangent, we'll go from negative pi over 2 to pi over 2. Cotangent, we'll go from 0 to pi. So without further ado, when sketching the graphs of tangent and cotangent, it's often beneficial to first sketch the asymptotes. And the way that we're going to graph those asymptotes is we're going to, once again, say what's our beginning, what's our end. And then that's where we're going to put our asymptotes. So this time we can put those asymptotes there directly. Halfway between the asymptotes is where cotangent and tangent have, it's really called a point of inflection, but it's going to be the 0, or it's going to be where it hits the equilibrium point. Not really the equilibrium when it comes to tangent, but that's kind of the reference we had before. Halfway between the x-intercept, I guess we can say the x-intercept. Halfway between the x-intercept and the asymptote is where cotangent and tangent equal 1 or negative 1. Or if you have an amplifier, it's a or negative a. And you'll see that I'm going to graph that, you'll see that in my graphing. So the graph of 3 tangent x plus 2. So first thing that we're going to do is, just like before, we're going to establish we do have a vertical shift of plus 2. Second thing we're going to say is what's inside. We're going to set what's inside equal to negative pi over 2 because this is tangent. We're going to set what's inside, this is our start. And our end is going to be x equals pi over 2. And it's kind of hard to see if I don't have anything inside the parentheses or inside the tangent. It's hard to see any kind of difference, but basically we set what's inside equal to the beginning and the end of our period. So I'm supposed to graph from negative pi over 2 to pi over 2. And just occurred to me, new set of notes. So with new set of notes, what's the first thing we look for? Equilibrium. Second thing we look for is the beginning and the end, just kind of like I showed there. Third thing we're going to do is we are still going to break this into fourths. Fourth thing we're going to do is we're going to establish all of those fourths on the graph. And we're going to establish the beginning was the asymptotes, and then, well, and then halfway through. It's a lot harder to describe it. It is, and just do it. So as I said, first thing we did was equilibrium, and I have that equilibrium on there. Then my beginning and my end is from negative pi over 2 to pi over 2. So let's scale that, and I'm still going to be doing this by fourths. So let's go ahead and put negative pi over 2 here and pi over 2 here, just so we have nice even boxes that we can work with. Now, the beginning and end of our period is going to be our vertical asymptotes. And then halfway between those asymptotes, as I mentioned in the directions up here, is going to be the 0. Now that 0 is going to be that x-intercept along what is the equilibrium. And then halfway between those, we have, that's where tangent equals positive or negative 1. So what I mean by that is halfway between on my tangent graph is where tangent is going to equal 1 or negative 1. Because I have an amplifier here, because that amplifier is 3, we are now going to go 3 above my equilibrium and 3 below my equilibrium to establish my points. Now, a big difference between the tangent graph and the graph of y equals x cubed is y equals x cubed does have a slope of 0 there. This does not have a slope of 0, and in fact has a slope of 3 for anybody who's really interested. So please do not draw that with a horizontal slope there. We can continue this graph on if we want to go another pi units, and I do want to know that that distance is pi. So if we want to go another pi units, we can replicate this graph one more time. Asymptote, halfway between the asymptotes is a 0, and then we use our a value to say 3 below and 3 above. And then we can establish the graph of tangent one more time. So our domain, how did we do it before? X is not allowed to equal one of those asymptotes plus the distance, that's why I had that pi, that distance to the next asymptote. Our period does equal pi because there is no b value. Our range is always negative infinity to infinity for tangent and cotangent, and there are no amplitudes for tangent and cotangent. So for b, first thing we're going to look at is what is that equilibrium, which in this case is negative 1. The second thing we're going to look at is we set what's inside equal. This is cotangent now, and cotangent, our normal graph of cotangent goes from 0 to pi. So we're going to set 2x equal to 0 for our start. We're going to set 2x equal to pi for our end. That's going to give us x equals 0 and x equals pi over 2. So I need to put x equals 0 and x equals pi over 2 on this graph, but I want to make sure that I include that I have 4 equal parts. So what I'm going to do is x equals 0 is nice to start with. I'm just going to make 1, 2, 3, 4 equal parts and say this is going to be my pi over 2. So cotangent has asymptotes at the beginning and the end, just like tangent does. Halfway between those is going to be the 0 or the x-intercept along the equilibrium point. Now, cotangent's graph does start off at positive infinity and then goes to negative infinity. So because of that, our cotangent graph will start at positive infinity. But now this amplifier of 2 causes us to be 2 above the x-axis, halfway in between, and 2 below axis, halfway in between. So we get our graph that looks like so. And I can't make a full period over here, so let's go backwards. I'm going to count 4 boxes. Count 4 boxes backwards. Halfway in between the asymptotes is the 0. We take our amplifier above and our amplifier below, and that's how we're going to graph the rest of this. So what is our domain? X is not allowed to equal one of those asymptotes, which I'm going to go ahead and say 0. And then the distance from here to here is pi over 2. We can say that as pi over 2 minus 0. So our period's pi over 2. So our domain is X is not allowed to equal 0 plus every pi over 2n. Range is all real numbers for tangent and cotangent, and the amplitude is none. This one's going to look a little crazier. So first thing I'm going to do is establish my equilibrium at 0. Second thing I'm going to do is say where does 4x plus 3 pi equal 0? And where does 4x plus 3 pi, actually, that's not 0, that would be, because this is tangent, that's negative pi over 2. Because this is tangent, this is pi over 2. So 4x equals negative pi over 2 minus 3 pi is negative 7 pi over 2. And then x would then be negative 7 pi over 8. 4x will equal pi over 2 minus 3 pi is negative 5 pi over 2. So x would equal negative 5 pi over 8. So how do I fit this nicely on a graph like so? What I would encourage you to do is let's go by pi over 8. So negative pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, negative 5 pi over 8, negative 6, negative 7 pi over 8. Now we are off the graph, and honestly, I would prefer to, well, I'll say that here in just a second. The negative 7 pi over 8, we do have an asymptote. Negative 5 pi over 8, we also have an asymptote. Rather than graph all the way off the graph, let's just go ahead and shift it over one full period because the tangents are all going to look the same. So I'd prefer to keep this on the graph as much as possible. So this is a positive tangent graph. So halfway between the asymptotes is my 0. And honestly, I can graph a bunch of those just to show the consistency. Halfway between that is going to be 1 and negative 1. And that would be 1, negative 1 in this case, purely because the a value is 1. And then we sketch the curves in. Et cetera, et cetera. So our domain, x is not allowed to equal. I'm going to look at that asymptote. I just randomly chose it. So negative pi over 8 plus, well, what's the distance between this asymptote and this asymptote? What is pi over 8 minus negative pi over 8? That would be pi over 4. So that actually is our period too, pi over 4. Our range, negative infinity to infinity, because all real numbers, and there is no amplitude. And the rest is just similar to that. So first thing, equilibrium. Second thing, 1/3 x minus pi over 2 equals, this is tangent. So I'm getting the bad habit of putting 0, so negative pi over 2. So 1/3 x is going to equal 0, so x equals 0. Then 1/3 x minus pi over 2 equals pi over 2. So 1/3 x will equal pi, so x will equal 3 pi. So I have to fit 0 to 3 pi on here. So let's go ahead and say 1, 2, 3 pi. So x equals 0 is my first asymptote. X equals 3 pi is my second asymptote. Halfway in between those is going to be my equilibrium point. And then this is a positive 2 tangent. So halfway in between those, which would be right about here, that's going to be like 3/4 of the way. So I go 2 down and 2 up to sketch my tangent graph. So my domain, x is not allowed to equal 1 asymptote, which I'm going to say is 0. And then the distance in the next asymptote is 3 pi n. So my period's 3 pi for that reason. We could double check. Our period is going to be pi divided by the b value. So what's pi divided by 1/3? That is indeed 3 pi. And then range, negative infinity to infinity. And there is no amplitude for a tangent graph. Couple of things are going to happen with this graph. We do have some shifts. So you have that b value, which is going to affect things. This is a cotangent graph, and it's a negative cotangent. So how's that going to affect everything? Well, we can take a look at it. First things first, we say, what's our equilibrium? Our equilibrium is going to be a positive 3. Second thing, we set what's inside. Because this is cotangent, and cotangent does typically go from 0 to pi, we set what's inside equal to 0. We set what's inside equal to pi. So we have 1/2 x will equal pi over 8. So x equals pi over 4. So our beginning is pi over 4. We have 1/2 x equals 9 pi over 8. So x equals 9 pi over 4. So we have to go from pi over 4 to 9 pi over 4. Now I only have 6 boxes on here, so I don't want to go by pi over 4s because then I'm way off my graph. So we are going to go by pi over 2s, and this is going to be a little bit of a compression of a graph. So pi over 2, pi, 3 pi over 2, 2 pi, then 5 pi over 2. So our end is going to be at 9 pi over 4, which is halfway there. Our beginning is at pi over 4. This is the beginning of our cotangent graph. Now, halfway in between there, we should have our 0. So if I'm counting boxes, I do have like 4 equal boxes. So halfway in between is my 0, where it hits equilibrium. Now, this is a negative cotangent graph. So cotangent would typically be up here because it would start up and go down. But because it's a negative cotangent, those get reflected over the equilibrium. And voila, this actually looks like a tangent graph. So a tangent graph and a cotangent graph are very similar to each other. Our domain is going to be x is not allowed to equal. Our first asymptote was a positive pi over 4, not a negative pi over 4. So x is not equal to pi over 4 plus, what's our period? Our period is pi divided by 1/2, which is 2 pi, which we can honestly see by counting in between there as well. So pi over 4 plus 2 pi n. Our range is from negative infinity to infinity, and there is no amplitude because this is tangent. Oh, one more. We have another negative cotangent graph. So as a negative cotangent graph, this should look like a tangent graph at the end as well. So we begin with our equilibrium. From our equilibrium, we're going to establish that 2x plus 3 pi over 2 equals 0. 2x plus 3 pi over 2 equals pi. And then let's solve. So 2x is negative 3 pi over 2. So x is negative 3 pi over 4. 2x equals negative pi over 2. So x equals negative pi over 4. So I have to go from negative pi over 4 to negative 3 pi over 4. I could go by pi over 4s. Let's go ahead and spread this out and say that's negative pi over 4 there. That's negative 2 pi over 4, negative 3 pi over 4. So that's the beginning of my cotangent and the end of my cotangent. Halfway in between those is my equilibrium. And then this is a negative 4 cotangent. So just like I mentioned before, this would be a positive 4 cotangent graph, but we want a negative 4, which is going to look like a tangent graph. So it's very, very stretched out. Domain, x is not allowed to equal negative pi over 4 plus, well, what is that distance? Let's go ahead and find it algebraically. Our period is going to be pi divided by the b value of 2, so pi over 2n. Our range goes from negative infinity to infinity, and no amplitude. If I wanted to continue that graph, I could do that over here as well and continue it on. So our last goal, just like we did before, where we wanted this to look like a, we wanted to write the equation of this as both a tangent and a cotangent graph. We did this with sine and cosine just because the two are very similar. Now, what we do want to do is find what are the asymptotes. So it's going to be important for us to be able to establish where some of these asymptotes are. So I'm going to go ahead and graph those. So here are my asymptotes. So with the asymptotes, then if I go halfway between those asymptotes, then we should be able to see halfway between negative pi over 12 and that ends up being negative 4 pi over or negative 2 pi over 3, so negative 8 pi over 12, negative 7 pi over 12. So halfway in between should be right there. And if you notice, that is a shift down one. So we could write this as negative 1 plus, and we want to do this as a first a tangent graph. So if you remember the tangent graph, that point that we have here is typically at the origin, or at least, let me go ahead and pull up that graph. So that point is typically at the origin, so that reference point is going to be the most helpful for us. We could use the asymptotes if we really wanted to, but I'm going to use that reference point. And actually for the cotangent, I am going to use the first asymptote as what our shift is going to be, because we want to know what was at the origin and how that origin point got shifted. So how the origin point got shifted, I want this as a positive tangent graph. That origin point got shifted to the right pi over 3. So that'd be x plus pi over 3. And then what is our b value? So what is the distance from negative? I'm going to go from like these points just because it's a little bit easier for me to think through. What's pi over 6 minus negative pi over 3? That would be pi over 6 plus 2 pi over 6, which is 3 pi over 6, or pi over 2. So kind of like what we did before, where our period was pi over b, our b value is now going to be pi over our period. So pi divided by pi over 2 is 2. So that is going to be our b value. And then we need to figure out what our a value is. So if we go halfway between there, which I'm going to go ahead and count boxes, 1, 2, 3, 4, 5, 6. I have 6 boxes. So halfway between those boxes is 3 boxes. And this distance right here is going to give us our a value. That distance looks like 3. So this is a positive tangent graph. I could also have negative 3, and I want a cotangent graph, which would have a coefficient of 3 as well. The period does not change. What's going to change is what the shift is and whether we want this as a positive or a negative. Well, if you remember the problems we had before, the negative cotangent graphs looked like the tangent graphs. So there should be a negative cotangent graph. Now, what is our shift? This is where I'm just going to identify one of these asymptotes, and this is going to be the easiest one for me to look at. So one of these asymptotes, this is a shift to the left, pi over 12. So we would write this as plus pi over 12. And I got pi over 12 because it's half of pi over 6. So for this one, this looks like a positive cotangent graph. So I'm going to start this off as a positive cotangent graph. Now, we can see that we have some nice asymptotes. Those asymptotes are at 0 and pi over 3. So as a cotangent graph, this should not be shifted at all. And I'm looking at that asymptote to show that it's not going to be shifted. So halfway in between gives us our equilibrium point, or what was the equilibrium point for sine and cosine. So that is a vertical shift down. So for both the tangent and the cotangent equation, that would be a vertical shift down of 1. Halfway between those are, there are 8 boxes in between. So halfway between that equilibrium point and the asymptote is 2 boxes. This tells us that our a value is going to be 2 because that distance is 2. So this is a positive cotangent graph or a negative tangent graph. Now, as a cotangent graph, we don't have a horizontal shift, so I'm going to put x minus 0. As a tangent graph, we could see that this was shifted to the right pi over 6, so I'm going to put that as x minus pi over 6. Now what we're left to find is the b value. So our period, we could see from that distance, is pi over 3. So our b value is going to be 2 pi divided, or not 2 pi, just pi divided by pi over 3. So that gives us the b value of 3 to finish our equation. So the graph of tangent and cotangent, there's a lot of similarities between sine, cosine, secant, and cosecant. But the big difference is, for tangent, we're going to start at negative pi over 2 and go to pi over 2. For cotangent, we're going to start at 0 and go to pi. The period of both of those is pi. But then the rest of the graphing is very, very similar to what we did before. So good luck with your work, and I look forward to seeing you guys next time.